Hello everyone, this is my 16th lecture and today we shall discuss about the Gauss theorem and its proof. The first of all we shall discuss about the statement of Gauss theorem, and according to Gauss theorem we know that a magnet is electric flux linked with a closed surface. We have studied that an electric flux E dot dA for any surface region, and for closed surface we put a circle on the symbol of integral, and integral E dot dA for closed surface is always equal to the ratio of algebraic sum of all charges contained inside the surface to the permittivity of medium. This is the statement of Gauss theorem. Again, I am repeating: the electric flux, the net outward electric flux linked with a closed surface, a closed Gaussian surface, is equal to the algebraic sum of all charges enclosed by the surface, algebraic sum of all charges enclosed by the surface to the is equal to the ratio of algebraic sum of all charges enclosed by the surface to the permittivity of medium. Permittivity of medium. This is the statement of Gauss theorem. Again, I am explaining. The net outward flux, electric flux linked with a closed Gaussian surface, is equal to the ratio of algebraic sum of all charges enclosed by the surface to the permittivity of medium. Gaussian surface must have two characteristics. Number one, a Gaussian surface is always a closed surface, and the electric field intensity on every point of Gaussian surface is always equal. That means all Gaussian surfaces are closed, but all closed surfaces are not Gaussian surfaces. Only those closed surfaces are Gaussian surfaces that has electric field intensity equal at their every point. And mathematically it is expressed just like that. Integral E dot dA is equal to summation Q upon epsilon naught. One or two point. We also discussed the net outward flux. We know that the electric line of forces are entered in a closed surface and electric line of forces comes out from the surface. The number of electric line of forces entered in the surface is negative electric flux, and the number of electric line of forces comes out from the closed surface is the positive, and the net is always equal to the outward minus inward, and it is equal to the summation Q upon epsilon naught. This is the statement of Gauss theorem. Now we shall discuss about the proof of Gauss theorem. Proof of Gauss theorem. For the proof, we consider a charge particle, pointed charge particle situated at point O, contains charge plus Q, and a distance R. We consider a point P. Now we imagine a closed or consider a closed Gaussian surface in the shape of sphere of radius R. Then the electric field intensity, if we want to calculate the electric field intensity at this point, the direction of electric field intensity will be this, because we consider here the positive charge and it is repelled by this positive charge. So direction of electric field intensity will be it. And now we consider an element area dA, which is also perpendicular to the surface, that is along the direction of E. So dA and E are both are along same direction. Consider a charge plus Q at point O and P is a point at distance R from O. Then directions of electric field intensity, and surface element area dA are along same direction. Now, electric flux linked with the dA, d phi is equal to d phi E is equal to E dot dA. E and dA are along same direction, so E dA cos 0 and value of cos 0 is 1, so E dA. Then electric flux linked with whole Gaussian surface. Whole Gaussian surface, phi E is equal to surface integral E dA. Then phi E is equal to E can be taken out, integral dA, because electric field intensity is same at every point on Gaussian surface, and we know that electric field intensity due to a single point charge at distance R is kQ upon R square into 4 pi R square is the area of sphere. So we can put Q upon value of K 1 upon 4 pi epsilon into R square into 4 pi R square. 4 pi and 4 pi cancel out, R square and R square cancel out. So net outward flux linked with the Gaussian surface will be equal to Q upon epsilon. This is nothing but the statement of Gauss theorem. Means the charge enclosed by the Gaussian surface to the permittivity of medium. This is the proof of Gauss theorem. So Gauss theorem contains, and one or two point we also remember that net outward flux means number of electric line of forces entered and comes out from the surface. The number of electric line of forces entered into the surface are taken with negative sign, and the number of electric line of forces comes out from the surface are taken with positive sign. So net outward flux is equal to outward positive flux minus negative flux. And all charges enclosed. We also studied that there is no R in the Gaussian surface case or in Gauss theorem. So the flux only depends upon the algebraic sum of charges enclosed by the surface. It never depends upon the surface area and the size of the Gaussian surface.